The Fantastic Voyage was one of the first movies to really introduce the concept of miniaturizing highly advanced technology, which back in the 1960s was a submarine, to small scales that could easily traverse through your body and access previously inaccessible regions. Now, we've seen examples like this in the media, such as in Ant-Man or the Magic School Bus, but we've never really seen anything come to fruition that can be used clinically and at this small size scale with that much complexity. The closest thing we really have these days is the capsule endoscope, which functions just like a regular endoscope, but instead of being a tube attached to a doctor's hand, is a capsule that a patient swallows and autonomously travels through your GI tract. Now, there's two primary challenges, really, or limitations that the capsule endoscope doesn't really address. So one of them is that photographs only give you so much information. Now, what we're trying to do to address this is develop our own integrated system, but instead of taking photographs, collects biochemical information based on reacting with specific fluids in your GI tract. And the way that we do this is by using specific sensors with different coatings for reacting with these specific biomarkers, and integrating this with a microelectronic system that enables both multiplexing for multiple types of biochemical reactions, but also a wireless signal transmission for external analysis. Now, the second primary limitation of the capsule endoscope's approach is that it only takes pictures of regions where it physically goes through. And this makes it difficult to assess regions that are not directly a part of your GI tract, but are still essential to digestive function. Now, what I'm referring to specifically here is the pancreas. Now, the way that your pancreas interacts with your small intestine is via a small tube at the beginning, where it secretes fluids consisting of enzymes critical for digestion, but also for neutralizing the acids incoming from the stomach. And so what we've done essentially to target this fluid specifically is use polymeric coatings that fill gratings in our capsule and would dissolve at those specific pH changing events. So where the acid becomes neutral, it dissolves at that point and allows us to specifically interact with that pancreatic secretion. Now, what's really nice about this device concept is that not only can we tailor the polymeric coatings for dissolving at different regions based on their pH, but we can tailor the biochemical reactive sensors to respond to different biomarkers and possibly be applicable to different conditions. But the only other real limitation, other than our own imagination, is ourselves as individuals and the patients. If we're willing to try new foods, why not try eating some new technology?